We have all enjoyed the benefits of a satellite, don't we? In the form of telecommunications, in the form of satellite channels, and all this, right? Now, how does a satellite reach its exact position? And how do astronomers deal with that position? How can they say, okay, now the satellite is in this position, or now the satellite is moving to this particular position? How do they deal with all these things? To deal with all these things, they use hyperbolas and hyperbolic functions to deal those. Now, in this session, we will be learning about what is a hyperbola and what are the different characters in the hyperbola, and also the equations of different types of hyperbolas. Now, in the beginning of conic section, we studied how we get a hyperbola. And how do we get that? If we have a double napped cone, suppose this is the double napped cone I have here. And now in this double napped cone, if I am cutting a plane which is like this, so there is a plane which cuts the double napped cone like this. And now what is the shape that you will be getting there? On the upper nappe, you will be getting a shape like this, maybe. And on the lower nappe also, you might be getting a shape like this. I mean, this might be interchanged, but you might be getting a shape which looks like this, right? Now, we have seen these two as individual shapes as a parabola. Now, what is this? Two shapes which are looking similar, facing opposite to each other. That gives us what? Hyperbola. So, this is how you get a hyperbola. When you cut a double napped cone in a plane, with a plane like this, you get two sections from that double napped cone, and that gives us what we call it as a hyperbola. Now, we cannot define hyperbola as this, like when somebody is asking you, you cannot say, okay, take a double napped cone and cut it like this and you get a hyperbola. No, we need an exact definition of a hyperbola. And what is this exact definition? I'll tell you. So you have a set of points, take a set of points or a collection of points whose difference from the two fixed points is always a constant. Okay, so remember this carefully. The set of all points, or the collection of all points, or the locus of all points whose difference of distance from two fixed points is always a constant, whose difference of distance from two fixed points is always a constant. So that is how you define a hyperbola. Now, what is this hyperbola? Let's draw that hyperbola here. So to draw that, I'm having an x-axis and y-axis over here. From the double napped cone, I might get two shapes like this, right? So I have drawn these two shapes also. So I'm taking a point on that red path, which I'm marking it as P1. And this point P1, from two fixed points, I have said in the definition that from two fixed points, the difference is always what? A constant. So I'm taking one point over here and another point over here. Okay. And now if I take this distance, this one and this one, and I'm marking these points as F1 and F2. So what is the difference here? What is the farthest distance? P1, F2. So I'm taking it as P1, F2 minus what is the shortest distance? P1, F1. So P1, F1. This is the difference between the fixed points for the point P1. And now if I'm taking another point over here, say P2, and if I take this distance, that is P2, F1 and P2, F2, what is the difference here? It is P2, F1 minus P2, F2. Yes, clear. Let's take a third point. A third point I'm marking here it as P3. And now the distance is, this is P3, F1 and this is P3, F2. So what is this? Here the difference will be, the farthest one is P3, F2. So P3, F2 minus P3, F1. Now this is the difference of the points from two fixed points, F1 and F2, right? Now this distance should always be what? A constant. Then what? You get a hyperbola. So this distance that I took here should be equal to one another. And if they are equal to one another, you can say the collection of points will definitely form a hyperbola. Hope you understood how we get a hyperbola, right? Now, in hyperbola, we will have different terms that we have to study. Same like ellipse, parabola and circle, we have different terms over here, and what are they? So let's draw a hyperbola again. So in the previous slide, I have drawn two fixed points, right? So again, I'm drawing those two fixed points over here. So this one and this one. F1 and F2. Why did I mark it as F1 and F2 there itself in the previous slide? It's nothing but these are the foci of the hyperbola. So F1 and F2 suggest what? The foci of hyperbola. F1, F2 is the foci of our hyperbola. And foci, same like for an ellipse, we represent using C. So what will be the coordinates of the F1 and F2? F2 will be C comma 0 and F1 will be minus C comma 0. So this will be the foci coordinates F1 and F2, right? Now for the hyperbola, since the hyperbola is touching the x-axis at a point, so you can see this one is meeting at a point over here. This is a vertex of the hyperbola, and same like that over here also there is another word. So there are two vertices. So this one is a vertex, I am taking it as A, and this one as A dash. Now this one coordinates will be A comma 0 and this one will be minus A comma 0. Same like how we say it for a ellipse. So A0 and minus A0. Now this is the vertex of the hyperbola. So remember the vertex of our hyperbola. And now you can see that there is an x-axis, there is a horizontal axis and there is a vertical axis. The horizontal axis is nothing but called as the transverse axis. So what do you call the horizontal axis in a hyperbola? You call it by the name transverse axis. And the vertical one, the perpendicular one to the transverse axis is called by the name conjugate axis. So you have one transverse axis which is the horizontal one and the one which is perpendicular to it called by the name conjugate axis. And these two, that is conjugate as well as the transverse, meet at a point which is called as the center of the hyperbola. So what is this? The center of our hyperbola. And now the length of the transverse axis, look at the length of the transverse axis. You can see that it is from here to here, right? Yeah. So what will be the distance from minus A0 to A comma 0? It will be nothing but 2A. So the length of transverse axis is nothing but 2A. So this is 2A. And this length, it is A, and this length is how much total? It is 2A. Now, what will be the other one, the conjugate axis? The length of the conjugate axis is nothing but 2B. You cannot see B here, right? So this point over here and this one, I am taking it as 0 comma B and 0 comma negative B. Okay, so this is how you get all the required terms or the points inside or the coordinates inside a hyperbola. So you have A0, you have 0B and you have C0. And the other one that is on the opposite side, you have minus A0 and 0 minus B and minus C comma 0. Now this is the length of the conjugate axis as well as the transverse axis. Now what is the distance between the two foci? Since it is Z0 and minus C0, the total focal distance will be, that is equal to how much? 2C. Now what is the distance, what is the relationship between C, B and A? We have studied that in the previous conic sections also as an ellipse and parabolas also. What is the relation between C, A and B? You have studied that in an ellipse, right? So what is that relationship? The relationship is nothing but B is equal to root of C square minus A square. What is B? Which is equal to root of C square minus A square, or from that you can also write C is equal to root of A square plus B square, or also you can write A is equal to root of C square minus B square. So these are the relationship between B, C and A. So this should be noted while doing problems because the relationship is always very important. Now moving on to the next thing, what is that? Eccentricity of an ellipse. So what is the eccentricity of an ellipse? How can you define eccentricity? Eccentricity of an ellipse, not an ellipse, eccentricity of an hyperbola. So what is the eccentricity of a hyperbola? You can say that, what is the meaning of hyperbola? Hyperbola has a definition which tells us that it is excessive. So if hyperbola is excessive, what should be its eccentricity? The eccentricity should always be greater than or equal to 1. So it's sure that hyperbola means excessive and its eccentricity should be greater than or equal to 1. And you know what is eccentricity. What is eccentricity? Eccentricity, or E, is defined as the ratio between the focal distance and the distance from one of the vertex. So what is the focal distance? You know that it is c. And what is the distance from one of the vertex? It is half of 2a, that is a itself. So eccentricity is equal to c by a. Now in a hyperbola, you know that the foci f1 is here, that is c comma 0 is here, right? This is c comma 0 and this is a comma 0. So the distance from focus from the center will always be greater than the distance from the center to the vertex. So c will always be greater than what? A. C will always be greater than a. So if c is greater than a, eccentricity means c by a, right? Since the numerator is always greater than the denominator, the eccentricity value will be greater than what? 1. So understand that eccentricity of an ellipse is equal to, not equal to, eccentricity of an ellipse is greater than 1 always. Understood? Now one more thing is there. What is that? The latus rectum, the length of the latus rectum. The length of latus rectum. Same like in ellipse that we have learned, the latus rectum length will be L is equal to 2b square by a. So here also the length of latus rectum is nothing but 2b square by a. So this is all about the different terms in a hyperbola. Now we have to know what are the different types of equations that we can give for a hyperbola. So let's look at the equations of a hyperbola. There are two types of hyperbolas that we can draw. One having the axis on the transverse one and the other one on the conjugate axis. So what are the two types of hyperbola that you can draw? The one will look like this and the other one will look like this. So there are two different types of hyperbolas that we can draw. Now the first case, what you can say the equation, since this is on the conjugate axis, the equation of this hyperbola will be x square by a square minus y square by b square equal to 1. So this is the equation of this hyperbola, the first one, or having the axis on the conjugate axis, having the axis on the transverse one, that is x square by a square minus y square by b square is equal to 1. And here you can see that now here it is on the conjugate axis. So in this case, this will be 0b, 0a, this will be 0a and this will be 0 minus a. And now you can say that here on this case, the equation will be y square by a square minus x square by b square is equal to 1. So these are the two equations for a hyperbola. So remember carefully, x square by a square minus y square by b square is equal to 1 for this type of hyperbola. And for the second type of hyperbola, it is y square by a square minus x square by b square is equal to 1. Clear? So that is how you find the equations of the two different hyperbolas. Now let's do some questions to understand what is the foci of an hyperbola, what is the ellipse, what is the eccentricity, what may be the transverse axis length, conjugate axis length, so all these things. So let's do some questions and find out those things. So you have a question over here to find the coordinates of the foci, the vertices, eccentricity and the length of the latus rectum for the hyperbola. Equation is given as x square by 16 minus y square by 9 is equal to 1. So from this equation, what you can see is, we can compare it with the standard equation. We know that we have a standard equation which is like this, x square by a square minus y square by b square is equal to 1, right? This is a standard equation for the hyperbola that we have studied. So if I compare with the given equation with the standard one, I can see that x square by 16 or x square by a square. So I can say a square is equal to 16 or a is equal to how much? Plus or minus 4. So I got a. And same like this, I will be getting b. What is b? B square is equal to 9. So b is equal to plus or minus 3. So I got a as well as b. Now, I also know what is the relation between a, b and c. What is the relationship between a, b and c? We know that c is equal to root of a square plus b square, which is nothing but root of 4 square plus 3 square, and that is equal to 5. So you got c also. Now, they are asking us to find out what is the coordinates of the foci. Since this hyperbola is having the foci on the x-axis or the transverse axis, I can say the foci will be plus or minus c comma 0. So what is the foci? The foci will be plus or minus c comma 0. And what is that c? It is 5. So it will be plus or minus 5 comma 0. So this will be the foci. Now you have the vertices. What is the vertices? What is the coordinates of the vertices? that will be plus or minus a comma 0. And what is the value of a? That is 4. So it will be plus or minus 4 comma 0. So that will be the coordinates of the vertices. Now eccentricity is nothing but c by a. The c value here is 5 and the a value is 4. So 5 by 4, that is the eccentricity of the hyperbola. And length of the lattice rectum L is equal to 2b square by a. So putting that value 2 into b square is how much? 3 square by a is how much? 4. So you get it as 9 by 2. So this is the length of the lattice rectum also. So that is how you get the different foci, vertices, eccentricity, all the coordinates, and also the length of the lattice rectum from the given equation of a hyperbola. So this is just we have to do. Look at the equation of the hyperbola, compare it with the standard equation, get all the coordinates of the foci and whatever things they are asking us to find out. Now there is one more question. Find the equation of the hyperbola with foci 0 plus or minus 5 and the vertices 0 plus or minus 3. Previous case, they gave us an equation, asked us to find out what are the coordinates of all the other foci, vertices, all this, etc. Right? Here in this question, they are asking us to find the equation of the hyperbola, giving us the foci and the vertices. So, what is the equation of the hyperbola? There are two types of equation we have studied: x square by a square minus y square by b square is equal to 1. Here you can see that the foci 0 plus or minus 5. So if it is 0 plus or minus 5, you know that the foci is not on the x-axis or on the transverse axis, it is on the perpendicular or the conjugate axis. So since that is on the perpendicular y-axis, you have to take the equation as y square by a square minus x square by b square is equal to 1. So this will be our standard equation of the parabola. So you can see that y square by a square minus x square by b square is equal to 1. Yes. And now I can say that this a over here is nothing but the vertices, that is 0 plus or minus 3. So a is equal to plus or minus 3. Now c, what is c? You can see that it is foci having on the coordinate 0 plus or minus 5. So c is equal to plus or minus 5. And what is the relationship between c, b and a? You know that c, b and a has a relation, that is c is equal to root of a square plus b square, or b is equal to root of a square minus c square, and from that, not a square minus c square, you can say that b is equal to root of c square minus a square, and from that you get root of 5 square minus 3 square, which is nothing but root 25 minus 9, that is root 16, or b is equal to how much? Plus or minus 4. So value of b is plus or minus 4. So you put all this in the equation here, you will be getting y square by a square or 3 square minus x square by b square or 4 square, that is equal to 1. And finally, you can write it as y square by 9 minus x square by 16 is equal to 1. So this is the final equation of our hyperbola with foci on the y-axis and also the vertices which is on the y-axis. Understood how to find the equation also. So in this session, we have learned how to find the equation of a hyperbola, as well as from the equation how to find the foci, vertices, and all the lattice rectum, eccentricity, and all the other characters in a hyperbola also. So throughout this chapter, we have studied different types of conic sections, starting from circles, then moving into parabola, ellipse, and now finishing with hyperbola. Hope you all had a great session. For the time being, let's just summarize this session.
Manorama Horizon. Learning made simple.